Good day everyone. Today we will discuss a new topic, which is simplifying radical expressions. We have the following characteristics to check whether a radical expression is already in its simplest form. Number 1, there is no factor in the radicand that can still be extracted as its root. Number 2, the index is greater than the exponential power of the radicand. Third, the radicand is not in fraction form. Number 4, there is no radical in the denominator. And number 5, the index of the radical and the exponents in the radicand have no common factor except 1. Again, take note of the following characteristics for us to check whether a radical expression is already in its simplest form. Let us consider the following examples. Let us simplify the square root of 32. Okay, first, take note of the factors of 32. And what are the factors of 32? We have square root of 16 and 2. 16 times 2 is 32. One of them is a perfect square. And for number 1, we have the first characteristic. There is no factor in the radicand that can still be extracted as its roots. Okay, so we need to extract the square root of 16, and the answer is 4. Square root of 16 is 4, and then 2 will remain inside the radical. Let's proceed with number 2, square root of 1/2. We all know that square root of 1/2 is also the same with square root of 1 and the square root of 2. And based from our characteristics, this is a number 4. There is no radical in the denominator, so we need to remove the radical sign here in our denominator. So we need to rationalize. Multiply it by the square root of 2 all over square root of 2. So we have 1 times 2 is 2, so we have square root of 2. And then 2 times 2 is 4, and the square root of 4 is 2. This is now our answer for number 2. Okay, next, number 3. The cube root of x raised to 5. For number 3, we need to apply the laws of exponent. And we all know that cube root of x raised to 5 is also the same with the cube root of x cubed times x squared. So 3 plus 2 is 5. Next, cube root and then x cubed, that will be cancelled. So bring out x, and then what's left is only the cube root of x squared. Next, number 4. Cube root of 2/3. Okay, the characteristic represented by number 4 is we have still there is no radical in the denominator. Characteristic number 4. So going back, we need to find a number that when we multiply it to 3, it will give us a perfect cube number. So what do you think is the answer? That is 9. Very good. Before that, we all know that the cube root of 2/3 is also the same with the cube root of 2 and the cube root of 3. And since 9 should be multiplied to 3 for us to get a perfect cube number, so let us multiply. cube root of 9, cube root of 9. Okay. Next, compute. 2 times 9 is 18, so we have the cube root of 18 all over. The cube root of 3 times 9 is 27. We all know that 27 is a perfect cube number. So let us now simplify. Just copy the numerator, cube root of 18, and then the cube root of 27 is 3. 3 times 3 times 3 is 27. Next, number 5. 1 all over 2 plus square root of 3. Again, characteristic number 4, there should be no radical in the denominator. So we need to conjugate. In conjugation, we need to find the conjugate. Copy the binomial and then change the number sign. So here we have 1 all over 2 plus square root of 3. Again, conjugate means we need to copy the binomial, but we need to change the sign. So we need to copy the denominator 2 minus square root of 3 and then 2 minus square root of 3. Just change the sign. So let's compute. 2 minus square root of 3 all over 2 FOIL method. 2 times 2 is 4. 2 times negative square root of 3, that is negative 2 square root of 3, and then square root of 3 times 2, we have plus 2 square root of 3, and then positive square root of 3, and then times negative square root of 3, that is negative square root of 9. Combine like terms. Copy your numerator 2 minus square root of 3 all over. So this will be cancelled out. 4 minus the square root of 9. And we all know that the square root of 9 is 3. So 4 minus 3. Let us now simplify. 2 minus square root of 3 all over 1. Or just simply write the answer 2 minus square root of 3. This is now our final answer. Next, number 6. The square root of AB plus square root of B all over the square root of A plus the square root of B. So we need to multiply it by its conjugate. So copy the denominator, just change the sign. Square root of A minus square root of B equals, let's multiply AB times A, that is A squared B. Then AB times B, negative B, that is negative AB squared. Square root of B times square root of A, that is square root of AB. Positive square root of B times negative square root of B, that is negative square root of B. All over FOIL method, A times A, that is A squared, minus A times negative B, B times A. You have AB, and then positive square root of B times negative square root of B, we have negative square root of B squared. Now let us simplify. So this will be cancelled out. What's left is, we have the square root of A squared B. This is A square root of B. Next, minus square root of AB squared. This is B square root of A plus square root of AB And then minus b, square root of b squared is just b. All over, copy. Okay, square root of a squared is just a. Then the sign minus square root of b squared is only b. This is your final answer for number 6. Next is simplifying radicals by rationalizing the denominator. If you could still remember, we are done with this and it was introduced to you when we were still discussing our first quarter lessons. So let us try to recall by answering the following. Number 1, the square root of 3 all over 2. This is also the same with the square root of 3 all over the square root of 2. And we know that the denominator should not contain a radical. So we need to rationalize this one by multiplying square root of 2 all over square root of 2. The value of the denominator will be multiplied to your numerator and denominator. So square root of 3 times 2 is 6. And then square root of 2 times 2 is 4. So square root of 6 all over square root of 4 is 2. This is now our answer for number 1. Number 2, square root of 3 all over square root of 5. So we will multiply it by square root of 5 all over square root of 5. 3 times 5 is 15. 5 times 5 is 25. So copy square root of 15 since it is not a perfect square. And then 25, square root of 25 is 5. Next, number 3. 6 all over cube root of 2. So in order for us to look later on for a perfect cube number, we need to think for a number that when we multiply by 2, we will extract the perfect cube. And that is, very good, the cube root of 4. Okay, so let's multiply. 6 times the cube root of 4 is 6. Cube root of 4 all over cube root of 2 times 4 is 8. And we know that 8 is a perfect cube number. That's why we chose the cube root of 4 to multiply with our numerator and denominator. So let us simplify. Just copy your numerator, 6 cube root of 4 all over 2. Because 2 times 2 times 2 is 8. And we can still simplify this. 6 divided by 2 is 3. So we have this as our final answer. Next, number 4. Square root of 2x all over 3y. So multiply it by, this is the same with the square root of 2x all over the square root of 3y. Multiply it by the square root of 3y all over the square root of 3y. So we have the square root of 2x times 3y is 6xy all over the square root of 3y times 3y is 9y squared. Okay, simplify. Just copy your numerator because it's not a perfect expression. All over, the square root of 9 is 3. And then this will be cancelled out. So what's left is just y. This is our answer for number 4. Next, number 5. The square root of a all over 3b. It is, the answer will be, could not simplify further. So this is just the answer. It is already simplified. Number 6. How about the cube root of 3 all over 5? Okay, we cannot simplify it further as well, but we can also refine it to decimal form. This is equivalent to 0.8434 and so on. Number 7. 5 all over square root of x plus square root of y. So we need to multiply it by its conjugate. So again, conjugate means you need to copy the denominator but change the sign. Okay. So let's multiply. We have here 5 times square root of x minus square root of y all over square root of x plus the square root of y times the quantity of square root of x minus square root of y equals, okay, just copy your numerator because it can't be simplified any further. So 5 times the square root of x minus the square root of y all over, so square root of x times square root of x is square root of x squared, and that is just x, plus minus, so the sign is minus, square root of y times square root of y, that is square root of y squared or just y. This is now our answer for number 7. Next, number 8. 3 minus the square root of 3 all over 9 plus the square root of 5. So, conjugate again. Multiply by 9 minus square root of 5. 9 minus square root of 5. Okay, so we have here 3 minus the square root of 3. And then 9 minus square root of 5 all over 9 times 9, that is 81. Positive, negative, so negative. Square root of 25. 5 times 5. Okay, simplify. Copy the numerator. 3 minus square root of 3. 9 minus square root of 5. All over. Square root of 25 is 5. So 81 minus 5 is 76. This is now our answer for number 8. Number 9. So here we need to use the radical rule, or we have the nth root of a over b, which is also equivalent to our nth root of a and then nth root of b. So the fourth root of 1 over 8 is the same with the fourth root of 1 all over the fourth root of 8 equals, so this is just 1, and then the fourth root of 8, just copy. So in this case, we can just get the decimal value, which is equivalent to 0.5946, or you can rationalize it if you want. So in this case, I just showed you the decimal value. So last but not the least, number 10. 2 all over square root of 3. So we need to rationalize. 2 square root of 3 all over 3 times 3 is 9, and the square root of 9 is 3. So that ends our discussion in simplifying radicals by rationalizing the denominator. Same with simplifying radical expressions by following the given 5 characteristics. Thank you and God bless.